Hi, welcome to another edition of Antique Radio Archaeology. Today I have three microphones that I really need to get restored, and I'm going to go ahead and get started on them. The first one is a candlestick style microphone. I believe it's made by the Kellogg Corporation. I'm not sure of the model number. The models on those, gosh, they started making them in about 1929, and they go all the way up into the 40s, late 40s, early 50s. So it's really hard to tell without tearing it apart and seeing what's inside as to what model number I might have. So that's one I'd like to restore. I have two what they call chauffeur mics. They were typically used in vehicles to talk on an intercom, but they were also used, believe it or not, in some radio broadcast places, amateur radio, and also by consumers to try and talk over a radio, depending on how the thing was wired up. So the first lollipop style mic, I call it that because it looks like a giant lollipop, is made by the Connecticut Telephone and Electric Company, and the other one is an RCA Bakelite type microphone. So all three of them are carbon mics, and all three of them are in need of repair / restoration, and we're going to go ahead and do that and test them all out at the end. Okay, as you can see, there's a lot of rust here. I need to definitely do some corrosion control here. There's a little sticker on here. Unfortunately, there's not enough information on the sticker to really tell me anything. Looks like I have a Bakelite handle that's definitely seen some use. It appears almost as though somebody tried to clean it and wound up busting through the top layer of Bakelite and reaching the kind of the brown underneath. It may be another material. I'm not sure. I'm going to have to take a look at it a little better. Has a little cast iron push to talk button. This is what leads me to believe that it's a Kellogg, the shape of the mic itself and this portion right here. So but I do need to identify what model, and the only way I can do that is to get inside and start looking at the circuitry, and that will tell me a little bit more about it. So let's go ahead and get started on disassembling. Alright, I want to go ahead and remove that felt. Well, that's one side. There. That's the base. No markings, unfortunately. And boy, I'm missing a lot here. There's supposed to be a circuit board in here. Well, that kind of sucks. So I'm not going to get a lot of information out of this one. But I can still go ahead and restore it to a point, at least aesthetically. So I'm going to go ahead and do that. Yep. Darn. Okay, so. Let's just fit on there. Okay. Missing some screws. And there we go. Well, it appears, so these two wires, yeah, go all the way up into here. I should be able to fish them out. I may regret that. Yep, I already am regretting it. There we go. Took a little bit. To figure out what's up in here, but I've got some information on this. April 45. Okay. With April 1945, that tells me that this is a 1945 model of, I'm assuming Kellogg, because it says KS&S company. But anyway, okay, that gives me some information and gives me an idea what I have here. So, meantime, I'm going to try and get this thing apart so that I can go ahead and clean it up and restore it. That ring comes off. Very fine thread. I believe this just slides off. It does. Alright. Interesting. There it is. As you can see though, there's the end of that screw on the side. So it's not going that deep into this thing at all. But I think if I can get this screw out, I'll be in much better shape. Boy, that thing's locked on there. I'm going to try and hit it with some penetrating oil. Okay, so did get it to move finally. I think that's a brass screw too. Oh my goodness. Alright, so there we go. There, okay. Alright, so there's just a pin there that needs to be knocked out, and that should free the rest of this up. Oh yeah. Alright. There we go. Take this thing apart, why not? this inside, but I don't think I need to. But what I am going to do is this. Put these little pieces together. I can leave these on here. Figure out if this is two pieces or one. I think this is all one solid piece of Bakelite, which I believe it is. Wow, it's crazy. It's heavy. Alright, so I can polish this up, which I'll do. This together. Alright. So I got a couple of things I'm dealing with right now. The biggest one is humidity. Right now we're projected to have rain pretty much through the rest of the week. I need to get this thing done. So I'm dealing with humidity, and as you may or may not know, lacquer and humidity do not mix. It's just such a hard thing to work with, and these need to be lacquered. So I'm going to get these things prepped. These are the base. This thing really just needs to be, I got to get that thing, the rust off of this. There's some rust around the edges here. Not too much on this, just some light sanding should get those taken care of, but I need to get these done and ready to go. And then I need to paint, so I don't know how that's going to work out, but we'll see. Like I said, I'm running out of time. I need to get this done, so. Alright, I'm going to go ahead and polish this thing up. Alright, so Okay, so put a little strips back here. There. Now, there we go. I'm going to go ahead and pre-wire this. I do not have all the stuff to make this the correct mic. This came in a version where it didn't have push to talk. It just went straight to voice, and that's how I'm going to wire it. I just need to put on a little card here and some terminal lugs so that I can do that, and then a little tie down there. Okay, so I found a terminal strip. I'll go ahead and just attach that there. There we go. Alright, so alright. There you have it. So really all I want to do is repaint that handle and repair this wire. And that shouldn't be rotating like that. Okay. Now, this is interesting because these are carbon mics, which means there's carbon in a little pot. I'll show you here in a minute if I can get this off. Damaging it. Yep, there it is. So you can see there's a little pot full of carbon. Make sure I don't lose any of that. Alright. Yeah, sort of did it. Oh wow, it moves around. There's the diaphragm. Okay. You know what? I don't need this wire from here on anyway. Okay, so I did a little research on this microphone, and what I discovered was this is actually called a handy mic, and as it says here, it's made in, through the Connecticut Telephone and Electric Company out of Meridian, Connecticut. And one of the things I found was this handle is actually the way it's supposed to be. So this is really in incredible shape. The only problem I have is this right here is loose, so I'm going to go ahead and put a blob of solder on that just to kind of secure that, and then we're going to go ahead and do the repairs on this. I need to get this here soldered, or get a wire for it and solder it, so let's go ahead and do that. This wire here is in really bad shape. You can tell it's crackling, so it's breaking apart, literally breaking apart. There's just no good wire left. As you can see, it just crumbles. It's just all crumbling to, yeah, so that's trash. There, got it. Okay. So that's taken care of. Now, last step, fun part. Go in here. Alright, so what I'd like to do now is go ahead and put the carbon back in the little pot here. Snap this thing back together. Now I've added some carbon to the original mixture, so there we go. Fully restored chauffeur's mic. Well, this one's made by RCA, and they're basically carbon mics. This one is broken on the top. If you open it up, there's the diaphragm. There was carbon in there. There's nothing, really. Nothing left. So what I'm going to do is I'm going to clean this thing up. I'm going to install this cable on it, and we're going to go ahead and put some more carbon in there and get this thing working. So not quite working the way I wanted it to. There we go. Finally. Alright. Got that out of there. Now, this stuff is called Litz wire. And that stuff's really hard to work with, because what it is you have a bunch of strands that are basically wrapped around pieces of silk. So soldering it's a pain in the royal buttocks. This isn't working too well. Well, soldering doesn't seem to be working here, so I got another plan. I'm going to use what's called a ferrule, and these are basically crimp-on terminals, connectors. And what you do, you have a special crimper. And that has given me a secure connection. Alright, so that's where it needs to be. I'll go ahead and melt all this wax back in here. Alright, it's not pretty, but it's usable. Okay, so what I'm doing now is I got some aquarium charcoal and get all the fine stuff out of it. I'm going to go ahead and fill this up with charcoal, or carbon actually, which is what it is. Alright, so, okay, now comes the fun part. Okay, so I'm going to go ahead and let that sit for a while. And then I'm going to go ahead and epoxy the top here, filling that in with black epoxy. Okay, I've done a few rounds. Finally got it. Okay, here are my three mics. I'm going to go ahead and test them on a mixer board here. It's going to an amplifier in another room. I originally tested it out in here and there's just too much feedback, so I went ahead and had to put the amplifier in another room just so that we can hear what the mics actually sound like. Well, before I test the mics that I just restored, I'm going to go ahead and do a quick test reference, and I'm going to just use this. I got a JMB mic. It's actually a pretty cheap mic, but it's a carbon microphone. And the thing about carbon mics, and it applies to all of the ones that I've restored, is you have to apply phantom power. And in this case I'm putting 48 volts of phantom power onto the mic. That gives it a bias voltage to work from. Without the phantom power you just won't hear it. It's just very, very low. So let's go ahead and give this one a test. Here is a reference test of a normal mic tied to the system. Test 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Test out. Okay, let's go ahead and start testing the restored microphones. Testing 1, 2, 3. Test 1, 2, 3.
Connecticut Telephone and Electric Company. Microphone. Test 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Test out.
Okay, this one sounds very tinny, very much consumer grade, but it works. So that takes care of one mic. I mean, it actually works better than I expected it to. Testing 1, 2, 3,
4, 5, 5, 4, 3, 2, 1. Testing the Kellogg T-32 microphone. It sounds pretty decent. You definitely want to keep some distance from the mic. I've got about 2 feet away from it. Don't want to get too close. It's a very, very sensitive mic, but I think it works pretty good. Test out.
Okay, this one sounds much better and very much like a professional mic should sound. It does, I mean, it's not as high fidelity as some of the mics today, but it does its job, and it's definitely extremely sensitive. When I had the amp in the room, it caused some incredible feedback. So anyway, this one works, so I'm calling that done. I really wish I had the push-to-talk function working. But we'll have to do that at another time. Okay, now we're going to do the little RCA mic, and I already know we're going to have some problems. Check 1, 2, 3. Testing 1, 2. Test, 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 test. Check, check, check.
1, 2. Test, check. 1, 2. Testing 1, 2, 3, 3, 2, 1. Test, test, test. Test 1, 2, 3, 3, 2, 1. Check, check.
Now, while this may have sounded okay in the amplifier, what you don't realize is while I was in here, I'm yelling into the mic. I'm talking very, very loud, and I'm talking very close to it, and I have my gains totally maxed out on the mixer board. That's not the way a mic's supposed to work. What I did find out, I did a DC measurement on this. I'm reading about 7 ohms. I should be reading about 40 to 50 ohms. I think what I did when I glued the cover on it, I think I had too much carbon in the little pot. And because this has a cone-shaped diaphragm instead of a flat one like the other mic did, it just pushed that carbon back and compressed it and made it extremely tight instead of spilling out like I wish it would have. So with it not being loose enough, I think I've created a situation where this mic is basically not usable, because you definitely cannot use it by having to yell into it. So it defeats the purpose of having a microphone to begin with. So the sensitivity on this thing is stupid bad. So anyway, 2 out of 3 mics we got working. This one, I'm not going to consider it a fully functional mic. I do need to do some work on it. I do need to do some work on the Kellogg mic. Really, all I need to do is get a switch that's built like a jack, and I do believe I have one, so I can modify it. I can get that push to talk working relatively easy. That's not a big problem. But by it not having that switch, if I had pulled the switch completely out of it, it actually would have been a T-48, which is the same mic without a push-to-talk switch. And the only reason why they produce those is those were used in PA systems where you're not keying the mic with the mic, you're keying the mic with the front panel of the PA system. So, so it is a functioning mic. I think overall we did all right. I could have done better, but you know, you win some, you lose some. So this concludes today's episode of Antique Radio Archaeology. If you enjoyed it, please hit the like button. If you'd like to see more content like this and you haven't already done so, please hit subscribe. In the meantime, happy restorations, everybody. Hope to see you next video.